For this problem here, what we've got is a basic system of linear equations, two variables, x and y, and two equations, x plus 2y equals 1 and 3x plus 4y equals -1. You can certainly solve this using techniques that you probably learned in grade 9 or 10 math. But we want to focus on setting things into matrices, augmented matrices, and then using row reductions to solve. So we're going to start by putting this into the augmented matrix. And basically what we want here is a column to represent the coefficients of every variable. So this will be my x column, and then I'll have my y column, so the two variables. And then on the right of that line, which is what makes the matrix augmented, I'm going to have my constant column. And then that's what the columns are going to represent. If we want to discuss what the rows are, they correspond to the equations. So this will be equation 1, and this will be equation 2. So we can just kind of read this left to right now. It's just grabbing the numbers. So x plus 2y, so there's an invisible 1, multiply by 1 for that x there. And then the multiplier on the y is going to be a 2, and the constant is a 1. So it just sort of like rewrites the equation, but instead of writing all the variables and all the extra information, it's its location in the matrix that tells us that. And the next row will be 3x, so 3 plus 4y equals -1. And so now we've got the matrix in place, and all that we're going to do from here is use those now row reductions, which correspond to the algebraic manipulations that we're allowed to do on equations. And we use these row reductions to try to get this into something simpler. Basically what that means for us right now is force zeros and ones. So if we look here, I've got this 1 here, which is good. That's what I like. I like a 1 up in that top left corner. It's really easy to use this 1 to force zeros and to basically cancel out other variables if you're thinking about your equation techniques. So we're allowed to add multiples of rows to another or subtract multiples of rows. And that's what we're going to do here. So I'm going to use this 1 to cancel the 3 by taking row 2 and subtracting 3 ones from it, but particularly the whole row. So row 2 minus 3 of row 1. And so I do that to the whole row because it's like subtracting the whole equation from the other one. So my first equation or my first row remains unchanged. And then I'm going to do 3 minus 3 times 1 is 0. That's the point. I wanted to force that 0. 4 minus 3 times 2 is 4 minus 6 is -2. And -1 minus 3 times 1 is -1 minus 3 is -4. So that's the first row reduction that we're allowed to use. There's a couple others. We're allowed to switch the locations of 2 rows at any point because it's basically just restructuring the order of the equations, which doesn't do anything. The other row operation that we're allowed to do is multiply a row by any non-zero scalar. So in this case, I said we really like 1s and 0s. So if I'm looking at this -2 here, I could certainly turn it into a 0 by adding the first row to it. 2 plus -2 is 0. But if I do that, it's going to turn this 0 into a 1, and it's going to undo the work I just did. So I'm not really going to be able to make that happen here. But instead, what I could do is turn this into a 1 pretty easily. 1s and 0s are going to be nice. And I can do that by just dividing it out. So what I can do is actually just take row 2 and divide out the -2. So do -1/2 of row 2. And that's the same as taking a whole equation and multiplying or dividing by a scalar. So if I do that, I will get 1, 2, and 1 for the first row. Again, haven't done anything there. But on the second row, I'll get 0, 1, and 2. And I could keep going. I could now force a 0 up here for this too. But I'm actually in a pretty good place to just go ahead and solve the equation without doing the matrix anymore. So what I'm going to do is just reverse that action of putting this into the augmented matrix. And I'm going to now put it into equation form. And it's all about location. So across the top, it's 1x plus 2y equals 1. Or I haven't actually done anything to that equation, but the bottom equation is now reduced pretty significantly because now it just reads 0x plus 1y equals 2, which in other words says that y equals 2. And then now if I put the first equation together with this result that I have with y equals 2, I get x plus 2 times 2 equals 1. So x equals -3. And so that's going to give me my solution set. x is -3, y is 2. And you should be able to check, plug it back into the original equations, and you should see that that works. It solves it.